Okay, we're going to talk about compute, but as part of our compute process, we are also going to do a lab. Let me just check on that really quick. Let me activate that whole thing, make sure everything's set up, right? Because we are going to talk about compute. We're going to talk about AMIs. We're going to talk about all the cool stuff around EC2 instances, because, you know, AWS is a panacea that will solve all of your business problems, right? Just kidding. I mean, AWS is actually really cool, but I don't think they're going to solve all your business problems. I wish that was true. I would have had less businesses go out of business. Anyway, all right, let's talk about compute. Let's talk about the lowest level of compute as far as just like the most control, you know, with the most, like the least operational offloading. So poll question, do you use EC2 instances or do you use Lambda? So let me ask a better question. How many of you are using either Lambda or containers in your deployments on AWS? All right, I got Timothy. Sean, good. Lambda and containers. Spectacular. Cool, Vinod, excellent. Love hearing that. Good. Wow, that's more than at any other time that I have ever asked that question by far. Usually I get one, maybe two, but 4 of you? That's unusual. Okay. So let's talk about virtual machines. And I think we talk a little bit about Lambda at the end, but this isn't the developer course, so we don't really deep dive that much into Lambda. But I say that we have a whole section on serverless, which we'll talk about API gateway and SNS and SQS and all that later on. Okay, so here's the needs. Our compute needs are moving in about a dozen different directions. And I know that none of you have ever gone in a dozen different directions for your projects at the same time. They're basically wanting to figure out a wide range of requirements, and they got to have some flexibility with their EC2 virtual machines, and they must do some cost management, right? Because if we had infinite amounts of money, you know what we would do is we would over-engineer the junk out of everything. But unfortunately, companies are in this weird little thing called making money, so you can't spend all their money doing the simplest things. Here are the questions. First of all, I love this for what's an AMI? That's a great question. We're going to talk about that. What compute services are there? That's another great question. We're going to talk about that too. How do I decide which EC2 instance type, like which type of EC2 virtual machine is best for my business? How do I do cost optimizations? And just to cap it all off, what is Lambda? Give me some broad strokes about how it works. Let's talk about it. Okay, now, even though Lambda is not in our architecture, it's in the upper left-hand side. It's like a little box. Excuse me. And here we've got some app servers. These are EC2 virtual machines, and they're in an auto-scaling group. I don't even think we talk about auto-scaling now. We're talking about auto-scaling later, but just know that those virtual machines on Lambda, that's a topic of conversation. By the way, I do want to just mention this to you, is that there's a lot of services like RDS, the relational database service, EMR, the Elastic MapReduce service, and EKS and ECS, which are both container services that can and rely on virtual machines for their underlying components. So just know that your knowledge here is going to be applicable there as well, because your licensing types will control how much you pay for those services, because EC2 is the unit of capacity. Okay, so let's talk about compute services first in general, and then let's talk about EC2 instances. Let's talk about the pricing options. Let's talk about instance storage, which you should never use unless you absolutely know what you're doing. And then we're going to talk about placement groups and high performance computing. And then we're going to skim the surface on Lambda, just so you know, have a general idea what it's about. Okay. If you're not taking notes, you probably want to take notes for this one, because the pricing options alone are going to be worth the gold of the certification. All right, so we've tested virtual machines, but is there a managed solutions to meet different requirements? Yes, absolutely. Now, first of all, there are a ton of options. Yes, we're going to talk about Fargate. Yes, 100%, Christian. So just know that all we're really going to talk about is we're going to talk about EC2, the different license types. I don't know why spot instances are called out separately. And then EBS, which is a conversation we're going to have just a little bit now and a lot later. And then Lambda, which we're going to have a little bit now. We're going to talk about all of Lambda's cousins later, right? But here's the deal. So Amazon wants you to know that they're cool. I think Amazon's cool, actually. So I'm cool with them like proselytizing their coolness. You know. So 2006 EC2 is out, right? 2014 the Elastic, is that right? I thought ECS came out in 2015, but man, I don't even remember. Anyway, the one thing I do remember is I remember when Lambda came out because I was like 2014. Are you kidding me? I didn't even think that, like, I thought they were ahead of their time. And then Fargate, which they tout as a separate product, which I'm just going to tell you is dumb. Okay. Fargate is a like variation on the Elastic Container Service and the Elastic Kubernetes Service. Why they mention it as a separate product, I have no idea. It doesn't function without the Elastic Container Service or the Elastic Kubernetes Service. So unless all of a sudden they're going to launch some new service that I don't know about, which is possible, you know, Fargate is a subproduct. And when you see Fargate, like if I ever meet the guy who named Fargate, or girl, let me not discriminate, you know, I would be like, hey, why did you call it Fargate? Why didn't you just call it serverless? Because that's what it stands for. It's just serverless Kubernetes and serverless container service. But anyway, that's me waxing poetical. So we'll move on. Just a little rant there. And then Amazon developed their own processors and started developing their own hardware, like the Nitro thing that Vinod was asking me about. They started doing that like years ago. Now, Gravitron processors really just hit mainstream, hit GA last year. Let me be very careful about this. If you see a G at the after the number inside of an instance name, it has a Gravitron processor. Those are ARM-based processors. They are not Intel x86-based processors. So make sure that your tooling has all been converted over. Otherwise, it won't work. Okay, so just make sure. Now, you may remember that I told you that there were 3 levels of hosting at the beginning of our entire conversation. I said, look, there's virtual machines, there's containers, which are run on virtual machines, and then there's serverless, which just means hidden servers. Now, notice they added Fargate in there, which all that is just serverless containers, which again, just means hidden servers. So just note that when you go from Lambda to serverless containers to containers to virtual machines, when you go from all, you know, these particular products, so we go from Lambda to Fargate, which is basically ECS and EKS Fargate, and you go to ECS and EKS EC2, and then you go straight to EC2, what you're doing is you step down is you're going from least amount of operational overhead to most, and you're going from the least amount of control to the most amount of control and flexibility. So Lambda is like super cool because you can run code and you don't have to manage the servers, and you don't have to manage scale, you don't have to manage any of that. But Lambda has some limitations, and it's really for event-driven architectures. EC2 virtual machines have a lot of flexibility, a lot of control, but you have to take full responsibility of the security profile and everything else. Okay, most amount of effort. So just remember that you got to choose based on what your security team is going to require you to do, right? Because managed services may not be supported by your company policy. But if you can get away with it, the higher you go, the less operational responsibility you have, which is kind of nice, honestly. Nothing like running an architecture that is 100% Lambda. You don't have to scale anything. It's actually pretty cool. So let's talk about virtual machines, which is, you know, considered to be the most control, but the kind of like rawest way to run services. Okay. So virtual machines launch on top of physical boxes. And we've been doing this since 2001. When VMware first launched whatever, their VMware Desktop, I think it was their first product, and then they launched quickly their enterprise products, the ESX, which later became vSphere. So these kinds of hypervisors, like the type 1 hypervisors versus type 2, which are operating system based, you still have an operating system on here. The difference between type 1 and type 2 is, was the operating system built for virtualization? Was the operating system not built for virtualization, right? That's really the distinction. So obviously Amazon's using type 1 hypervisors, assuming that I remembered that correctly. Right? And so what's happening is that they're running virtual machines on top of hardware, and in some cases they've designed the hardware. Now, these physical servers exist in the availability zones that we keep talking about. Now, what happens is that in order to boot that virtual machine, you have to tell Amazon what operating system you want, what kind of disk you want, what size is the virtual machine. And in order for you to boot it, you're going to have an Amazon machine image. Now, Amazon will provide Amazon machine images for you, or you can roll your own. Now, Amazon does have a service called the EC2 image builder. I think it's still a little bit of a smoldering dumpster fire. I would recommend that you use Packer, but honestly, you could use whatever tool you want in order to create your own AMIs. But these machine images are templates that you use to boot up an operating system. Amazon only officially supports really 3 operating systems that aren't like in the AWS marketplace: Windows, Linux, and Mac OS. That's it. Not Solaris, not HP UX, not AIX, not BOS, not OS2 Warp, not FreeDOS. Don't ask me about FreeDOS. Wait, I bet you somebody is out there who's gotten FreeDOS to work. That'd be pretty funky, actually. Anyway, bottom line is that these are repeatable, reusable, and basically recoverable machine images. And when you take one of these images, you could launch 50 to 5,000 virtual machines off of them. There's no limit, actually. My point being is that inside that image is everything it needs to boot up. Now you can pre-build them. You can grab them off the marketplace. You can roll your own. Most enterprises roll their own images. They don't actually, like, you. First of all, they definitely don't use community, which isn't even listed here. They don't necessarily buy a third party, which is what marketplace is, and they don't use Amazon's pre-built images per se. Sometimes they will, but only if they've modified it with some kind of CIS scanner to make sure it meets compliance. But just so you know, most enterprises roll their own AMIs. Again, Linux, Windows, Mac OS. So many comments. Now, the way this works is that you usually end up booting a virtual machine using Ansible, Chef, Puppet, Salts, Microsoft's, whatever they're calling it now, Configuration Manager, right? Maybe even Fleet Manager, Systems Manager inside of AWS. And what happens is the system will boot, it'll get configured automatically, and then someone will take a snapshot of it and convert it into an AMI. It's a great way to do it, but only if you are automatically configuring the system. If you're manually configuring that box, good luck. That's not how the pros do it, and that's not scalable. So just be careful you decide to do that. So you could create an AMI, and then with that new AMI, you could spawn multiple copies of that particular configured operating system. Now you can do something called instance user data, right? Where you basically change what the system does at boot time. You can actually have it run commands like PowerShell or Bash scripts or some variation thereof. So just know that you can have an image that has everything baked into it, like SQL Server or Tomcat or whatever, Nginx, whatever it is that you're doing. And when it boots, it's going to launch all that software. Now, I did mention the EC2 image builder. Just know that it's a product that's evolving towards good really fast. Not quite there yet. I probably would use HashiCorp's Packer if you want to create your own AMIs. It's getting close. It's getting really close. And soon, honestly, it'll probably be better than Packer. So keep your eye on it. But it doesn't have enough flexibility for me yet, and it doesn't have much flexibility actually. So remember, AMIs are Amazon Machine Images. They are used to boot an EC2 instance by providing it with an operating system and some other information. Now, as we move forward, one thing to note is that most of the time when we launch virtual machines, you are launching it with all of Amazon's other customers. They're in like a shared pool. Every once in a while, someone with a security or licensing requirement will come along and say, man, we can't launch that virtual machine and it can't be shared with other like of Amazon's invisible customers because we're not allowed to co-live or co-locate, cohabitate with anybody else other than our services. And so you can actually get a dedicated instance or a dedicated host, which allows you to launch multiple virtual machines that are like isolated to that particular piece of hardware. This, by the way, will allow you to exist on the same box again and again and again. So if you have like a per socket, per core, or per virtual machine software license, you can use the dedicated host to control that. This could be, by the way, RHEL, it could be SUSE Linux, it could be SQL Server, it could be Windows Server. So just know that if you have some restrictions here, that can be handled, right? So mainly just know, though, that dedicated host is the most expensive way to use AWS virtual machines. It is the most expensive way to use EC2. So if you decide to use dedicated instance and dedicated host, just know that it's going to be the most expensive thing you've done, right? On a per like machine basis. Shared tenancy is for every other licensing type, and it's very accessible. So just know, by the way, you also have to create your own VPC that has dedicated tenancy in order for this to work. You cannot run a dedicated host inside of a shared VPC, which is also known as the default VPC. Not the default, but a default VPC, okay? All right. Now let's talk about the sizes of these machines. So we talked about how to pick an operating system. We talked about how to pick where it's going to live, right? So just know that these letters and these t-shirt sizes make a difference. So there's only like 5 or 6 general categories of virtual machine. There's storage optimized, there's memory optimized, there's compute optimized, there's general purpose virtual machines, and then there's what's called graphics accelerated computing, which is basically just GPU machines. They have like GPUs in them. Great for machine learning and, you know, hashing and calculations and that kind of thing. The number is the generation of the machine. So if you see a C7 or sorry, a C6G, that is a 6th generation compute system, right? Which is what the C stands for. And the G stands for Gravitron. I got to tell you, the attribute names, the things that come after the number, those are the hardest things to keep up with. You know, it'll be like D for disks or G for Gravitron or A for AMD or I for Intel. I mean, and they're not always intuitive. So sometimes you're like, why is there an N there? Is that networking? And like, no, that's Nitro. It's like, oh, what? Right? So just know that if you need to like look this up, I've got a really great website for you. If you go to ec2instances.info, it got bought by a company called Vantage. Here's another. Oops, sorry, that just went to one person. Let's switch that. Instances.vantage.sh, also known as ec2instances.info. What this does is that, I think that was an M5N. Is that what it was? Yeah. Here's an M5N. Notice that it goes from large to 2x large to 4 to 8 to 12 to 16 to 24. Notice that when it does that, actually, let's sort by memory. Notice that, excuse me, when it does that, the amount of memory and CPUs doubles each time. That's the large, X large, et cetera, et cetera. M stands for median. This is a general purpose machine. And notice that there's a 5 there, which means it's the 5th generation. And the N, we'd actually have to look up. Like I think it's Nitro networking, but we have to look up. So I usually just type in EC2 instance types, and then I go actually look at the documentation. Now here is the general purpose types. Now, notice I said M or T actually is literally general purpose. There's A's in here. You might say, well, what's the N? All right, well, the N, neural networks. Oh, the Nitro system, that's what it is. It's the Nitro system that we were talking about before. It's a lightweight hypervisor with dedicated hardware, super fast, designed by Amazon, right? Now, that's all general purpose. If I went to the compute optimized instances, here we're looking at the C's. Oh, there is a C7G. I was just making that up. They must have just released that over at reInvent. Notice that these Gravitron processors are ARM based. Okay, so they're ARM based, not Intel based. And we've got memory optimized, which we've got the R series, and then the X's, right? Ignore that. And then we've got the P's and the G's, which make up the GPU instances. There's also F and B and other stuff in here. And then with storage optimized, it's I's and D's. Now I got to tell you, these instances are these IM4G. I don't even know. I haven't. These just got announced actually. Now, my point being is that you're going to want to know that there's general purpose boxes, compute, memory, accelerated, and storage optimized boxes. You're going to need to know that. The letters are helpful. So C for compute, M for median, and M and T for median for general purpose. R for RAM for memory optimized, G's and P's for the accelerated computing, and then storage optimized is going to be D's and I's, right? So in general, you probably want to know that. You probably want to know that you're going to use the latest generation. The rest of this, you're going to look up, honestly. If we go look at general purpose and I have no idea what the I is, I just click on it. I just happen to know, by the way, it's Intel. It says A, I just go look at it. I just happen to know that it happens to be AMD, right? But like, what is the A thing? Is that an ARM processor? Nope, it's still an AMD, right? Still an AMD processor. So some of them you can figure out. Some of them get really weird, like a GN. I guess that's a Gravitron with the Nitro edition. I is Intel, I'm assuming. Let's go check. Yeah, looks like it's Intel. Let's go look at the R series. That's probably Intel, Gravitron, AMD. What's a B? I don't know what a B is. EBS optimized? Okay, sounds good. So bandwidth optimized. Got it. So my point being is that you may not know the attributes, but you definitely have to remember the first letter, the second number. Like you always want to use the latest number. You don't have to remember what the current number is per se. And then remember the sizes. Is it going to be a small, a medium, a large, an extra large, right? Amazon is not going to test you on the t-shirt sizes. It's not going to test you on the attribute names. They're not even going to test you on the generation numbers. They might test you on, do you know your buckets? In other words, do you know how to break down these numbers? And do you know what the general categories are? In other words, it might say, if you need something that's going to be heavy on data crunching and processing, which of these like general types would you use? And you would say compute optimized because you're doing number crunching, right? They're going to tell you, for example, they want you to use the latest instance type because here the M5X large is actually faster and cheaper than the purple M4X large. They're going to tell you that to memorize that, you got to keep that in your brain, right? The other thing is that in addition to knowing just in general what these things kind of generally mean, they're going to want you to know that they actually have a compute optimizer, which means if you are not using your services optimally because you've got underutilized resources, they're going to let you know, hey, by the way, your auto scaling group probably could go with smaller instance sizes. Here's a recommendation. But that's all they do. They just make recommendations. Now, instances do have a life cycle. So when they have an AMI, which is that Amazon machine image, and you boot it up, you launch it, it goes from a pending state to a running state. Once it's in that running state, if it has a hard drive attached to it, which by the way, it should, because you want to use what's called the elastic block storage, you want to use that as much as possible. When it's in a running state, you can either reboot it or you can shut it down, which is also known as termination, or you can stop it, but you can only stop it if it has an EBS volume attached to the root drive. It won't let you stop a system that's using that drive with no EBS storage. It won't let you stop that system if it doesn't have, if it has an EBS, if it doesn't have an EBS root drive. Okay. So notice, by the way, that those cycles, you're not necessarily gonna have to memorize every single piece of them, but just know that you cannot stop an EBS rooted, I'm sorry, a system that is not EBS rooted. So if it's EBS rooted or EBS backed, you can stop it, which means you don't pay for compute anymore. You only pay for the storage. So it's a great way to stop instances that you're not really using. Now, when you boot a system, you can actually have it do things like install software, enable the software, hook into an Ansible server, hook into a Chef server. You can have it actually have it do things by having it execute at its user data level. Now, notice here that they're actually installing Apache web server in the top. At the bottom, they're actually installing an IIS Windows feature for Windows. This
So what's the purpose of using Ansible in the EC2 context?
Ansible is a configuration management system. So once you hook the system up to Ansible, it's going to run a full set of configuration. So Vinod, you would use either Chef, Puppet, Salt, or Ansible to configure the system with any last minute changes at post, boot, right?
Gotcha.
Yeah. That's a better way to do it. Most people are not using PowerShell and Bash per se to configure their instances on the last mile. I mean, I know some people are really good at Bash and PowerShell. I'm pretty good at Bash myself, actually. But just to say this is that most people are going to use some kind of configuration management system, because then that way everything can be kept as infrastructure as code. Now, this is the user data. There's user data, which is what we're going to ask the system to do at boot time. And there's metadata, which is information that we get about the system. Notice that in this particular case, there's an IP address in there, that 169.254.169.254. That is going to be on the exam, on the certification exam. You better memorize that URL, the /latest/meta-data or /latest/user-data, because that 169.254, 169.254 is going to be on the exam, because this is a way in which you can actually get information from inside the operating system. You can't run that URL except from inside of the operating system on an EC2 instance. When you run this metadata, this allows you to get access to this information and then retrieve what you're looking for. You might be looking for the public host name, the public IP address, the IPv6 address. You can actually run it in scripts by doing that. So remember, both the user data and the metadata can be retrieved using that URL. You just have to change metadata to user-data, and you can also get that information for the boot script. Okay. All right, I'm going to talk about this last thing, and then we're going to take a short break. So Amazon EC2 key pairs. So just be aware that when you first log in to either a Windows, a Mac OS, or a Linux box, in order to get access to the Windows and the Mac boxes, the Windows boxes, you've got to have the private key from an EC2 key pair that will unlock the public key lock. You also can use that with Linux to log directly in without using a password. Most systems now are using keys to log into a system, or they're using some kind of management agent like Systems Manager or something else. So just know these key pairs are generated inside of EC2. When you generate them, you get a private key, and it takes the public key and puts it on any EC2 instance that you launch, that you specify for, and then it uses the private key to unlock the public key. So you have to use that to log in. The other thing they want you to know is to remember about tagging, is that you need to tag everything inside as much as possible. So if you have an automated system for creating EC2 resources, just try to tag as much as you can. Who's the owner? What's the owner's email address? What's the billing code? What project is this for? Is this production, non-production? Right? Try to do that as much as possible. And then just know that if you wanted to wrap all this together, like put your AMI IDs and the network interface and your tags and your user data and all your hard drives and any placement groups or any kind of other instance, like you can actually put this into what's called a launch template. This is used, by the way, for auto scaling, spot fleets, on demand. Like this will allow you to create a pre-configured template for launching your EC2 instances. Now, there is another thing called a launch configuration, which is a little older. AWS is recommending that you don't use that. They recommend that you use launch templates instead. But this allows you to create predefined launch capabilities. And once you create this template, you can then just trigger the launch of it and say, I want 10 instances from this launch template. So it'll really minimize your deployment errors, increase security, help you better manage costs, all that stuff. So launch templates are going to come up a little bit later when we talk about auto scaling. Okay, that was just some general talk about AMIs, user data, metadata, the different states that an EC2 instance can go through. Does anyone have any questions before we take a short break?
I have a real quick one, Mike.
Go ahead.
I'm looking through the instance types, and on the EC2s, I see that a lot of the ones that are ending with a D in them, like R5D or the CGD, they resort to an M2 NVMe memory store rather than the EBS volume.
Well, those aren't exclusive.
Okay, that's actually what I wanted to get to is that exclusive, meaning I can't have both at the same time, or?
No, not at all. As a matter of fact, if you look at that EC2 instances.info, you'll notice, for example, that this class of systems is all EBS only. If we look down here and let's say, what's a good one? What were you looking at? Was it the
Do an R5DN?
R5DN, right? So
Yep.
Notice that these all have NVMe hard drives attached to them, but you don't have to use them. As a matter of fact, it's recommended that you don't use them unless you just need a scratch volume or a temp table or something, or you're doing some kind of vast batch processing. These should actually still be backed with EBS volumes as the root drive, and those volumes should be used as scratch volumes.
Okay, yeah, that's what I was really wondering is whether or not you could also attach the backup with the EBS.
Well, just
Cool.
to say this is that you don't want to use those as the root drive because you won't be able to stop the system. And if it crashes, you'll lose all your data.
Oh yeah. Yeah, it's all stored in memory. So.
Yeah.
All right, cool.
Yeah. Well, and the problem, Christian, isn't that it's so much stored in memory, is that when that system crashes and let's say it automatically reboots because you've set it in an auto scaling group or whatever, it's actually going to start on another host. So
Right.
you lose access to that physical drive. That's the problem.
Yeah, no, it makes sense.
Yeah. Yeah. And we thought Amazon was going to retire that, but I guess they keep getting free hard drives with these systems they're making. So they just keep making it available, which is kind of cool if you need a scratch volume. But honestly, so many people have kind of like hurt themselves by using these volumes that we kind of advocate that they don't do it unless they are really comfortable. So yeah, but that's what that is. So yes, you can mix and match instant storage and EBS all you want. Cool. All right. It is currently 2:39. Let's just say 2:40 just to be safe. Come back at 5 till 3, and we're going to finish out EC2, and then we're going to do a lab, and that will probably actually cap out our day. And we're going to talk about exams, obviously, as the very last piece. Okay. So go take a 15-minute, 16-minute thing. So I'll put up a little timer. This time I'll leave it up so you can actually see it, and we'll regroup at that time. Let's move on to pricing options, right? I mean, pricing options are probably the biggest determining factor about whether you're going to lose money or achieve maximum value inside of AWS with virtual machines. Probably the other one is, of course, are you using auto scaling or not? That's probably one of the big ones. So let's dive into this and let's talk about the different pricing options outside of dedicated, because I got to tell you, dedicated is not really a pricing option, even though it's the most expensive option. It's not really a licensing option that most of us are going to use, right? Now, these four things here, on-demand instances, reserved, savings plans, and spot, are going to be the four kind of general license types for shared tenancy. It is worth noting, by the way, that these options all have very different pricing structures around them, right? On-demand, which is in the far right, that is retail price. So imagine that that instance costs $1. You only need it for 3 months. That's what on-demand is for. Spot instances are only for applications that can withstand interruption. This is for like reporting applications or computational applications that can get a 2-minute warning and get shut down, because with spot instances, you're only going to have that instance for as long as you outbid other people for the instance. So if you're like, hey, Amazon, if you're going to give me an M6DN extra large, I will pay you, instead of $1, I'll give you 60 cents for that. And Amazon's got a bunch of extra unused capacity and they think 60 cents is worth their time, they'll give you that instance for an hour or 2 hours until somebody needs it. You can actually save up to 90% on costs, but spot instances are only for applications that are either stateless or can withstand interruption. By the way, you can mix spot instances with other instance types and get some pretty cool things going. These last two, the reserved instances and the savings plans, are actually two sides of the same coin. One is money focused, where you give Amazon a bunch of money and they give you a bunch of value in return for giving them money ahead of time. And the reserved instance type is when you say, Amazon, I want to buy 10 T3 micros in US East 1A for 3 years. And Amazon will be like, okay, we'll give you a 72% discount. So both the reserve instances and the savings plans do 1 or 3 year commitments, but in the reserve instance case, you are committing to use and pay for a certain amount of capacity every month. With a savings plan, you're basically saying, Amazon, I'll give you $10,000 if you give me like $14,000 or $15,000 worth of value. Amazon says, like, that sounds great. Let's do it. Amazon's, always, like most businesses, they want money now, right? It's worth more money than later, right? So it's for them, it's like, yep. Plus, just know that that allows them to be a little predictive with their capacity. So they love that when you're like, hey, I need this workload for 3 years in this one data center. They're like, great. We're definitely going to make sure we have enough capacity for that. Now, let's just talk about reserved instances, also sometimes called reservations. There are 3 actual types of reservations. There's standard reserved instances, there's convertible, and then there's scheduled reserved instances. Scheduled isn't listed here, it should be, right? Standard reserve instances save up to 72% of the type. That's 1 or 3 years, but they are very inflexible. If you say, I want 10 T3 micros in US East 1A with windows on them for 3 years, it's really hard to change that. You can sell it, but you can't really change it. Amazon doesn't really let you do that. The convertible instances will give you less of a discount, but in exchange, they're going to give you more flexibility. In other words, if you want to take those 10 T3 micros and smash them together and make 5 T3 smalls, they'll let you do that. If you want to take 4 of those T3 smalls and smack those together, crush them together, you can get 2 T3 mediums. If you want to smush those 2 T3 mediums together and get 1 T3 large, you can do that. Note that ability to put things together and break them apart is an attribute of convertible reserved instances. So you can actually modify the t-shirt sizes, right? Now, Amazon does have the marketplace, which will allow you to sell your reserved instances if you're like, all of a sudden you're like, I don't need them. But this is the answer if the workload is going to be running for a year or more, up to 3 years. You want to use reserved instances for the most part. If you need some flexibility, then you can look at convertible reserved instances, which will give you some flexibility around the size of the instances that you run. Now, if you need even more flexibility, you can actually use what's called a compute savings plan with a savings plan. And they don't care where you're running, what OS, tenancy, compute options. They don't care about any of that. They will give you a discount on any compute that you run, including Fargate and Lambda, right? So whether it's EC2, ECS, EKS, EC2, ECS, EKS, Fargate, whether it's Lambda, they don't care. They will give you up to a 66% discount on the money that you invest in them. And then they have EC2 only savings plans, which will give you flexibility around size, OS, and tenancy. But you're going to get 72%, but you have less flexibility. You can't switch regions and you can't switch instance families. So, and they also, by the way, have SageMaker savings plans, just so you know. So, was it Hunter? I think it was, yeah, Hunter. So just know that they have SageMaker savings plans for data scientists. So here, by the way, this is a little table. I don't know that you need to memorize this for the exam. I think in general, you need to know that convertible instances give you some flexibility on the size, right? And savings plans give you flexibility on the location and the size and the operating system. The main thing you need to remember is that these are 1 or 3 year term commitments. So if you're going to run your workload for a year or more, this is going to be your answer. Now, spot instances, unlike savings plans and unlike reserved instances, spot instances are you just asking, hey, Amazon, I don't want to pay full price. Do you have extra unused capacity? The hourly price for a spot instance is called the spot price. You can indeed get up to a 90% discount, but let's be clear about this. If you win the bid for this box, let's say you want to say 70 cents on a $1 box. If you win the bid, Amazon's going to give it to you, but they can take it away at any time with a 2-minute warning. You'll get a little notice and it says, hey, we're going to shut this down. So your software has to be constantly writing out data and doing checkpoints so it can withstand that kind of data, interruption, right? If the question on the exam says, and I repeat, if it says we're running an application that can withstand interruption, that means you're going to be using spot instances, okay? Pretty much that's pretty good trigger for that answer. Now, what workloads are great for spot instances? Well, basically anything that can be interrupted, right? By the way, this can be integrated into all kinds of fleets. So if you want EC2 auto scaling, if you want EMR, it can all be integrated into that as well. One thing that people do is they'll use reserved instances as their base. Then they'll use on-demand or compute savings plans to cover up like other portions of it to get more flexibility. Then they'll use spot instances if for this like burstable capacity. And if spot isn't available for whatever reason, they'll go to on-demand. So you can actually create automated systems using the fleet manager to create your own spot fleets or on-demand fleets that are part of an auto scaling group that will allow you to mix all these licensing types together. If you need 100% consistency and steady state on your workload, you're going to use reserved instances or a compute savings plan. If you need burstable capacity, and that capacity has to be there, it's going to be on demand. If you need burstable capacity, but it's like it can be extra, like it can withstand interruption, that's where spot instances are going to sing. Okay. So remember, we're not talking about dedicated. That's its own licensing option really in and of itself. But on demand is the second most expensive way below dedicated to use it, AWS. And then compute savings plans or EC2 savings plans are the next cheapest. Reserved instances are the next cheapest, and then spot is the cheapest. But remember, spot does come with the headache of You need to be able to withstand a 2-minute interruption, okay? All right. You definitely want to know that for the exam. They're going to ask you questions on costing around this. Okay, now let's say someone comes back to you and they're not concerned about cost, but they come back to you and say, I need something that supports 32,000 IO per second. Cool, because that's a disk drive, right? Well, the first thing you need to know is that Amazon has an elastic block store, which is its own virtual hard drive service. This is the predominant way that 99.9% of us use AWS. We do not use what's called instant storage. We use EBS storage to back that up. Now, this is typically a 1-to-1 ratio, meaning you've got one disk drive attached to one EC2 instance. And that one EC2 instance might have, 15 drives, to be frank about it. Typically less than that, but right. One of those has to be the boot volume, which is what EBS is used for. And notice that these disk drives only exist in one availability zone. Just like an EC2 instance, they can live in only one availability zone. Now, EBS, by the way, can be created, attached, used, snapshotted, detached, and then deleted, right? So just note that you have to attach it and detach it in order to get it to hook into the virtual machine. There is a thing, by the way, called multi-attach, which is very rarely used, where you can hook up one EBS disk volume to multiple virtual machines in the same availability zone. But please be careful with that. You can corrupt the file system super easy if you do not use a cluster file system on that volume, or you can put it in read-only mode if you want to. But just know that that's not a typical use case. Typically, an EC2 virtual machine will have the only thing attached to that disk drive. So volumes, by the way, can also back up your instances, and they can be converted into AMIs. They are stored by default. These snapshots are stored by default on a hidden portion of your S3 account. So you can only access them through the EBS interface, but they are on an S3 just for your own edification. You can, by the way, snapshot a running system and make an AMI out of it if you want to. So just know that you can create AMIs out of running boxes. Now here's some volume types. So you got GP2, GP3, IO1, IO2, and then ST1 and SC1. I just want to say this. I don't know why Amazon has the GP2s and the IO1s up there. It might be because they're still burstable, but honestly, you should be using GP3s and IO2s. I would try to avoid, they're cheaper and faster than GP2s and IO1s. So yeah. IO2, by the way, has a special version called Block Express that most people should know about. This one goes up to 256,000 IO per second at a 256K chunk size. So ridiculously fast. Now, the ones on the top are SSD based volumes. The ones on the bottom are mechanical. In general, you can't use the mechanical volumes as boot drives. So I wouldn't even bother using them unless you actually have a very specific use case to do so. Otherwise, you use the top volumes, the GP3 and IO2 in particular, for small random IO workloads. So GP3 is great for general purpose. That's what it stands for. IO2 is for databases that need high throughput. So if the question says, I need a disk drive for a high throughput database workload, just go ahead and put either IO2, or if they happen to have IO1 listed, use that one instead. But the answer is IO volume. IO volumes, by the way, have interesting characteristics. So you notice here that here is the whole mapping of like all of these volumes can go up to 16 terabytes, except for Block Express, which goes to 64. Notice that general purpose solid state drives will go up to 16,000 IO per second. And that provisioned IOPS IO1 and 2 will cap out at 64,000. Notice those transfer rates, by the way, at the bottom, the max throughput per volume. So you got 4 basically gigabytes for the IO block express. You got 1 GB for the provisioned IOPS, and you've got, looks like 1 GB for GP3, which is respectable. Yeah. So GP3 basically is where everybody goes, GP3 and GP2. By the way, you can convert volumes underneath the system. So not that hard to convert from GP2 to GP3 live, like with the system up and running. The mechanical hard drives, which is streaming throughput 1 and super cold storage 1. Those are my made up names, right? That's not what they actually mean. ST1 and SC1 are particular for like sequential workloads or just archival workloads. So just know that in general, you don't want to use ST1 and SC1 for anything other than kind of slower transfer speeds, or ST1 in particular is pretty good for sequential. But notice that those MIBI bytes are actually pretty slow when compared to these MIBI bytes. Still faster than GP2, but that's why I was saying just use GP3. Notice that they also cap at 16 terabytes or TB bytes. They're using base 1000, I think is why they keep calling it TI instead of TB. Okay. Now, that was all talking about EBS. You might have heard Christian and I talking earlier when he asked the question about instance storage, which is the storage that comes for free with some of your EC2 instances. This is NVMe SSD based storage. It's super fast. It's also super temporary. So one of the questions they frequently ask is, what happens to your instance store data if you stop an instant store backed instance? And the answer is that your data is automatically deleted. Woohoo! You lost your data. Well, maybe you wanted that. Maybe it was a security measure. I have no idea, right? So just know that instant storage is not commonly used unless you have temp tables or cache, or you've got an application that's going to write that data out to another system. But that's what instant storage is. Instant storage is local just to the host that the virtual machine's on. So if that machine either stops and gets restarted or is terminated, that data disappears. So don't use instant storage unless you want your data to be non-persistent.
So, sir, I read somewhere or heard somewhere that Redshift uses SSD or HDDs, and those are instance storage type. I may have read this long time back, so I may be wrong too. I wonder if they use instance storage, do they back up like the data all the time then? Or I wonder how do they take care of the data durability?
So my understanding is that Redshift is persistent durable disks. Their nodes are actually backed by durability. But let me just say this, is that I have never run a Redshift node. I've stood them up before, but I've never had to like troubleshoot or recover them. But the last time I was touching them, they had persistent disks. They weren't using temporary storage. So I don't know, but I'd have to look at the answer for that. But Redshift is persistent database. It's not an impersistent database.
Okay. Yeah. I mean, it's based off of PostgreSQL, so has to have some persistence there. Yeah.
Yeah, let me check that out, actually. I'll look it up and find out. But yeah, the nodes there that comprise a Redshift service, they are persistent storage. So I'll have to look that up, actually. That would be the first I've heard of that.
Thanks.
Yeah. I'm not saying, you could be right, by the way. I'm saying I gotta go look it up. I have no idea. That does sound weird though, but we'll find out. Just when we do the next lab, I'll look it up and find out what the deal is. Okay. So just realized we're at the last slide for that. Any questions about that as far as like any of the different pieces there?
So from a backup strategy perspective, I know you will be talking about it, but very, very quickly. So if if I was to back up EBS volumes, would it be better to keep taking snapshots, or do the EBS volumes always keep creating their snapshots? Or do I need to create an AMI out of the machine? I mean, some
So
guidance on backup strategy.
yeah, so you can actually use a service called AWS backups, or you can use like EBS, like lifecycle policies to control how long you keep things for. But I mean, you can keep as many EBS backups as you want. It's RDS is the only one that has, when it does automated snapshots, not manual snapshots, when it does automated snapshots, is the only one that has a 35-day limit on retention. But you can take as many manual snapshots of RDS as you want. But just to say this, when it comes to EC2, you can take as many snapshots as you want and you can keep them for as long as you want. Amazon's not going to throw any of your data away unless you ask it to, right? So my recommendation is just use AWS backup to create a policy for how your systems get snapshotted and how long to keep those snapshots for. So I would do that, because then that will keep costs under control while still adhering to whatever company policy. For example, you could say, look, I need to keep 30 days and then I need to do a first of the month backup. So I want to keep all the first of the months out for, a year. So you could set it so that you have 12 months at first of the month backups, and you also have the last 30 days. So you could do stuff like that. You don't have to convert it into an AMI to make it permanent. You can just keep it for as long as you want.
Thank you.
Yeah. Okay. All right. So let's talk about a little bit about high performance computing, right? So that's what this next one is about. When we talk about high performance computing, we're really talking about like intensive, like computational processing that requires like extremely low latency interconnects. Now, there's a couple of different ways to approach this. The first one for you to know is that, one, it's typically about the network bandwidth. And what Amazon approaches this from two different perspectives. One, how do I get all of your virtual machines on the same physical host? Because I got to tell you, that is really fast networking because it never leaves the physical host. If I do have to leave the host, though, this is where we've got ENAs, and EFAs, which is elastic network interfaces, elastic network adapters, and elastic fabric adapters. These are specialized upgrades that you can apply to your network interface to make it even faster. Now, note that ENIs are available to almost every instance by default. So notice that's up to 10 gigabits per second. The ENA is an add-on that you can throw onto a system, and it's only on supported types, right? But that enables what's called SRIOV, which is kind of like this virtualization enhancement. It almost like bypasses virtualization to create a lot of IO speed. That's going to go up to 100 gigabits per second. And then you've got this whole thing called an elastic fabric adapter, which is like a network fabric. And it literally will like bypass, in a sense, it's almost like its own operating system. It will bypass the OS. And it is also optionally supported on certain types. But notice you're going to get up to 400 gigabits per second on those interconnects. That traffic, by the way, is going to be limited to a single subnet, and it's not going to be routable. It's going to basically use what's known as SRD, which is scalable, reliable datagrams. Notice that it's not a TCP or IP setting, right? That is something very proprietary to HPC computing. So just know that EFAs require a little bit more manipulation to get functioning, but can get extremely fast. Now, I told you that Amazon comes at it from two angles. They either try to solve it by giving you a faster network card, or what they'll try to do is they'll try and place you on the same host. Now, if you don't tell Amazon where to place your instances, by default, in a same availability zone, they're not going to place your instances next to each other. They're going to try and keep your instances off of the same host in case that host goes down. Now, with the placement group, you can say, look, Amazon, I want you to place all of my instances on the same box. When you want it all in the same box, excuse me, that's called a cluster placement group. This happens in a single availability zone. So the cost of this is you're going to get performance. You're going to get 10 gigabits per second, but you're going to lose high availability, right? So just know that when you do this, when you lose high availability, that's a cluster placement group that brings everything together on the same physical host. Then you've got spread placement groups, which are a little different because it's going to make sure that everything is placed on a distinct rack, right, across a bunch of availability zones, all in the same region, of course. This is to maximize fault tolerance and resiliency and minimize, like, you're not going to get high performance necessarily out of this, right? And so we got clusters, which bring it together. We've got spreads, which spread it apart. And then we've got partition placement groups, which do a combination. What they do is they place you apart in the same availability zone, but then they put stacks of systems together. This is useful for specific things like Cassandra, Apache HBase, the HDFS file system, like the Hadoop distributed file system. This is a way of creating distributed clusters within the same availability zone. So you get the benefit of having these boxes together, but they are segmented from each other on these different like systems, these different physical hosts. So in summary, cluster brings everything together in the same box on the same availability zone. Spread moves everything out, right, into different availability zones in different physical hosts. Partition does this weird amalgam where it puts everything in the same availability zone, but pushes sets of boxes onto different hosts. So remember that a partition placement group like creates these partition sets, and those partition sets can then be separated onto different physical hosts in the same availability zone. Remember that spread is the only one that maximizes high availability. Partition and cluster do not maximize high availability. Questions about high performance computing? All right, we're going to talk about serverless and we're going to do a lab. Okay, serverless. Here's the deal. I said it before. If it says serverless, it means hidden servers, right? That's what's happening. Someone's hiding the servers from you and they're managing them all for themselves. They're not letting you manage them, which is good. You don't need to, right? So serverless computing, which in this case, Lambda is the service that provides this, is really just about providing code, and AWS handles everything else. Here's how this functions. You upload your code, you answer a few questions about how you want it run, you specify how it's going to be triggered, and then it runs. Now it runs for a maximum of 15 minutes, and there are t-shirt sizes for how big the process can be. But when you upload your code, you, for example, could ask for 2 processors and 10 gigs of RAM, right? Now, they're linked, by the way. So the more you go up in memory, then the processing power goes up. So they don't let you just randomly put your random processor size and your random memory size together. You have to use their t-shirt sizes. But just know that once this is invoked, it'll run for up to 15 minutes and then it'll stop. You might say, that sounds horrible, Michael. What if I want to run a 24/7 application? Might not be your best option here. But just to say this is that you can actually chain Lambda functions together and create a completely event-driven architecture. So don't feel like you can't actually run a 24/7 app. You 100% can. You just have to get comfortable with how to orchestrate it inside of Lambda, and it's not super complicated. This does support Node, Java, Ruby, C#, PHP. Well, is it custom runtime for PHP? But PowerShell, Go. You can see the listing there. Here's some event sources. Here's the bottom line. Pretty much anything can trigger Lambda at this point, especially if it can get to another service. SNS can trigger Lambda. CloudWatch events, also known as EventBridge, can trigger Lambda. There's a bunch of things that can trigger a Lambda now. What's the use case? Well, you know those servers you were using before that had cron jobs on them to do this and that were probably either running Perl or Python anyway, maybe some bash scripts. Well, this allows you to do that on something that's not a server, and therefore you're not paying for a server that's just sitting there burning through money. Right? Instead, when Lambda's not running, by the way, you don't pay anything. It just sits there. You only pay for execution time in Lambda, which is judged in milliseconds. So it's metered in milliseconds. That's all. Here, by the way, is a simulated slot machine browser game where someone's actually, you know, there's like a cherry, a puppy, and a robot there. That's hilarious. But basically, a client-side browser calls the script, right? And then it invokes the functions, returns the results, and then returns a response. But I've mainly used Lambda to, like, instead of running my cron jobs in a cron server, like on a Linux box, I've mainly used Lambda for all of my like various like administrative and system tasks. So it's ideal for that. I have helped orchestrate a bunch of applications on Lambda, which really surprised me. But event-driven architecture is what you want to look up if you decide to do that, because you have to be good at event-driven architecture in order to really pull that off. It's not hard, but most people don't really think about action, response, which triggers another response. They don't think of things that way. So Lambda, upload your code, t-shirt size, tell them what the triggers are, tell them what the permissions are, go. By the way, I mean, by default, I think you can run 1,000 concurrent Lambda functions in an account. You know, it will go much higher. If you want to talk to Amazon and raise it up to 30 or 40 or 50,000 executions a second, just justify it for your business. They'll do it. Questions?
Sir, it's a general question. You use this term t-shirt sizing, and at work also people use that. And honestly, I'm not very familiar with what exactly you're trying to say when you say t-shirt sizing.
Yeah. That's a good question, actually. So, for example, see how this says large, extra large, 2x large, 4x large, 8x large. T-shirts often come in those sizes, right? And so what they're referring to is they're referring to the size upsizing and downsizing based on t-shirt sizes, right? So yeah, it is definitely a colloquialism, but yeah, no, that's worth explaining actually. Yeah.
Okay.
Yeah.
Gotcha.
It gets even worse if you look at like a T3 series, for example. Nano, micro, small, medium, large, X large, 2X large. I don't know that I've ever seen a t-shirt called a nano or a micro, but I've definitely seen a small and a medium. But I can see, but not that way, that would be confusing, but that's what they mean by that.
Thank you.
Yeah, absolutely. Okay. So knowledge check. Which of the following is true of an AMI, right? Man, there's some pretty racy statements there. I gotta tell you, AMIs can only be obtained from the AWS marketplace. That's absolutely not true, because you heard me make a big deal about making your own AMIs. AMIs can only be used by users within a single account. No, you can remember, you can share AMIs out with the world if you want to. Now, this is where it gets tricky. You can launch multiple instances from a single AMI. Well, that's the whole purpose of doing it. So we clarified that D is definitely on the table. And then AMIs can specify the subnets for launch. Actually, no. I mean, a launch template can, but AMIs don't, right? So then what you're left with is AMIs can include block device mappings that specifies the volumes that you're going to attach to the system. And you can launch multiple instances from an AMI. So you end up with B and D as being the right answers. Now, remember, if it was as a launch template, you could specify other things in there, right? But the rest of those just aren't true. Okay. In the instance type M6G, which aspect of the name indicates the instance family, like what the system was designed for, and helps to determine the virtual machine's best use case? Yeah. So what family type does the M belong to? Because everyone wants to say memory, and that's not right, because that's not what the M stands for. R is for RAM, for memory. What does the M stand for? Like, what family type is the M series? That's right. It's a general purpose family. Good. Good answers. Which of the following are true regarding Lambda? Select two. Good. C and D. Seeing a lot of those answers. And that is actually the correct answer, C and D. All right. Do me a favor, by the way, everybody like who's going to do the lab, even before I talk about it, can you just switch over to this really quick and just go ahead and open the lab and hit start lab. I'm a little worried about the lab expiring because I actually talked for like an hour and a half when we took a break. So I'm a little worried about the lab expiring. So go ahead and hit start lab for me while I talk about the lab really quick, if you haven't already done that. Okay. Meanwhile, I'm going to talk about the lab. Here's what we're doing. You've got like 12 tasks in this one, of which, some of these are optional. So here are the tasks. So you're going to create an Amazon VPC in a region. You're going to create subnets. You're going to create an internet gateway. You're going to create a route table. This is going to be really involved. You're going to create a public security group, launch the EC2 instance into that security group, into that public subnet. Then you're going to test it out by connecting to it. And then you're going to create a NAT gateway, configure routing, create a security group for private resources. You're going to launch an EC2 instance into a private subnet. So now you've got one in public, you've got one in private. You're going to connect to the private instance. You're going to test connectivity between the two as an optional task, and you're going to figure out how to retrieve instance metadata. This is what we're doing for the rest of the day until I cover exam cram at the end of the day. Okay, so that's it. So if you look at the lab itself inside here, note that it just lists all the tasks that I gave you. That's all you got. So my recommendation is make sure you stay very, very detail oriented. Don't miss a step. Don't forget, like, pay attention to what you're doing. Let me know if it doesn't make any sense. But this is what you're doing until you get to the optional section. And when you get to the optional section, you're going to test connectivity, which, by the way, I think it should fail if I remember correctly. And then you're going to retrieve the instance metadata, right? Which that's going to be fun in and of itself. Okay. That's it. That's the whole thing for the remainder of the day. At 4:30, we're going to roll over to do some exam cram stuff. Okay. So that's it. So does anybody have any questions about this? Otherwise, you can go ahead and get started.